Hi, good morning. In this video, multiplication theorem and independent events. These 2 points I discussed. Multiplication theorem and independent events. These 2 points I discussed in this video. This multiplication theorem says the multiplication of the probabilities of the events one by one, one after one, the multiplication theorem says the multiplication of the probabilities of the events one by one, one after one. For instance, I'll give of a well-shuffled pack of cards, one card is drawn. Of a well-shuffled pack of cards, one card is drawn. That it is a jack, not replaced. I have taken a card, but I did not replace. The card is with me. Another card is drawn after taking one card. Okay. Next, I have taken another card. Second card I have taken. Not replaced. That it is a king. Another card is drawn. Not replaced. Another card is drawn. That it is. Another card is drawn. Again, it is also a king. Another card is drawn. It is an ace. Then the probability of this, you may be asked. I will tell you again. Well-shuffled pack is there. 52 cards. Well-shuffled pack. From that, one card I have taken. That is jack. Suppose. The probability you have to find that the first card is a jack, second card is king, third card again king, and fourth card is ace. Again I am telling, first card I have taken without replacement. Without replacement, every time I am taking successively, one by one, successively, one by one, one after one, I am taking without replacing, supposed to be. The probability that the first card be jock, second card be king, third card be also king, and fourth card ace. Like this, if it be the event of occurrence, what is the probability of that occurrence? That is the question. Question, if you understand, half solved. How many jocks will be there? Once I discussed this about cards, how many jocks will be there? 4 jocks. How many kings? 4 kings. How many queens? 4 queens. How many aces? 4 aces. So, first one is jock. So, 4C1 by 52C1. So, 1 jock. Probability of 1 jock. Probability of the occurrence of the event of 1 jock. Okay. Into, we are multiplying. That is why it is called multiplication theorem. into next king. How many kings are there? 4 kings. 4c1 by 51c1, because I have taken jock one card and I kept in my pocket. I did not replace. So how many cards in the pack? I have already taken one card. So 51 cards. So now king 4c1 by 51c1 into again king. Again king. Again king means one king, 4 kings only, 4 kings. So one king I have taken, how many kings will be there? 3 kings will be there. 3c1 by, from the total pack, how many cards I have taken? 2 cards I have taken. One time jock, one time king. So how many will be remaining? 50 cards. 50c1. So king again, 3c1 by 50c1. By 3c1, 4 kings, 1 king I have taken already. So 3 king cards will be there. 3c1 by 50c1 by, because 52 out of 52 cards, 2 cards I have taken out without replacing. So 50c1 into again ace. Occurrence of ace. How many aces? 4 aces. 4c1 by how many cards will be there? 3 cards I have taken. Out of 52, 49 cards will be left. So 49c1. So 4c1 by 49c1. 4c1 by 49c1. Yes, probability. So now we have kept every jock probability into king probability into king probability into ace probability. I have kept with all into marks. That is called the multiplication of the probabilities of the events one by one, one after one. That is called multiplication theory. Like this you will find. Okay, next. Independent events. Multiplication theory I discussed and independent theory I discussed. Independent theory. What is that independent theory? P of A intersection B intersection C equals to P of A into P of B into P of C. Intersections. P of A intersection B intersection C. Maybe up to N. No problem. Same procedure, same theory will be applied. So P of A intersection B intersection C equals to P of A into P of B into P of C. This is called independent events theory. From this we will have some properties. P of A equals to 1 minus P A dash. P of A equals to 1 minus P of A dash. P of A dash equals to 1 minus P of A. This is a good property. And another good result is probability of occurrence of at least one of A and B. Probability of occurrence of at least one of A and B. At least one of A and B. It should mind you, A union B. It is P of A union B. At least sounds P of A union B. So P of A union B equals to 1 minus of P of A dash into P of B dash. If A and B are independent events, this is a good result. P of A union B equals to 1 minus P of A dash into P of B dash, where A and B are independent events. So P of A and B you learned as additional theorem. The addition theory, P of A and B equals to P of A plus P of B minus P of A intersection B. That you have learned. So, same P of A and B can be giving us the different result. When A and B are independent events, it will give the different result. P of A and B equals to 1 minus P of A dash into P of B dash. This is another result. It is a good result. Many times it was asked, and it is frequently asked result. While doing sums, it is applicable. P of A and B equals to 1 minus P of A dash into P of B dash. Or else you can tell P of A dash into P of B dash equals to 1 minus P of A union B. So P of A and B can be expressed, P of A and B can be expressed with other result 1 minus P of A dash into P of B dash, where A and B are independent events. What is P of A and B? P of A and B is nothing but probability of occurrence of at least one of A and B is A union is P of A union B. That P of A union B equals to 1 minus P of A dash into P of B dash. These things I discussed in this video, and I have done some questions in my book and explained it. Please go through it without forgetting. At the same time, in addition to these things, in addition to this video, as you are watching, this is not sufficient. You have to do more exercise from NCERT textbook, from the topic probability, 12th class. Remember it. For all this, for you to watch my videos, you have to like, share, subscribe and click bell icon. This is very important, because if you don't do this, you will not get my videos updated. So some information I will give up to JEE mains exam or advanced exam. Though I may work in some colleges or some college, I will carry on my process of giving videos to you. You have to watch, carry on watching. Though I attend classes in some colleges or institutions. Okay, I will continue this. And this is, I am doing in my room. This is not the classroom. This is in my personal room. In my personal room, I am doing with my mobile. Some students are asking, why not on whiteboard or blackboard? On board, why not explain? We can explain, but this is my personal room. For that equipment and all that, board, marker and everything, I have to arrange one room for that. It is not available now, so later I will see about it. Don't worry about it, whether it is on blackboard, whether it is on whiteboard, not board. The thing is that whether the subject is reaching you or not, that is very important. And also you can meet me when I come to college, and you can talk to me about the subject. Okay, thank you. Don't forget to share, subscribe. Don't forget to click bell icon. so that you can get more updates. Okay, after this Bayes theorem, let us discuss. I think this is ninth video only on probability. This is the ninth video only on probability. So the videos may be a Bayes theorem will be there, distribution is there, binomial distribution will be there, distributions will be there, no, statistics will be there. So all will be, of course, maybe 15 videos, probability and statistics. Might be so, of course, I don't know. But I carry on doing, I go on doing all this. You get them update. For that, you please subscribe. Okay? And tell, mostly, this is, in my view is of making these videos is that for the poor students, for the financially backward students, because they are, some people are there, they contacted me, some people are there. For them especially, please pass on this news to the poor students who are studying in government colleges, and they will get subject. Though they are interested and they are aspirants of IIT students, they are aspirants of IIT, JEE, even then, because of no financial status properly, they are not able to join in corporate and in big payment colleges. Therefore, let me help some way, as I have some knowledge. So I would like to give some knowledge what I have to the poor students. They will also learn and they will flourish, and they will get, some of them will get some ranks. Okay, thank you. So pass on this news, tell your friends, mostly are studying, who are mostly studying in government colleges. Okay, thank you. Please go through the notes now. I have explained some illustrations to make you better understand about independent events and the multiplication theory. My dear students, today we are going to learn multiplication theorem on probability. It is very easy. You already learned conditional probability. P of E on F equals to P of E intersection F by P of F. In the previous video, you have learned it. This is equation number 1. Also, we can write P of F on E. How P of E on F we have written before. Similarly, we can write P of F on E equals to P of F intersection E whole by P of E. That is equation number 2. Since from the set theory, E intersection F is nothing but F intersection E. Again I am telling, since according to set theory, E intersection F equals to F intersection E. Everybody knows it. A intersection B equals to B intersection A. The common elements are the same now. Therefore, I have taken P of E intersection F equals to, do cross multiplication, P of F into P of E on F. P of F intersection E, do cross multiplication like this. P of E into P of F on E. These both are same, no, since E intersection F equals to F intersection E, according to set theory, P of E intersection F equals to, we have done cross multiplication, no, that value we will keep here, P of F into P of E on F. Here, P of E into P of F on E. This is nothing but multiplication rule. That's all. Very simple from the conditional probability. So P of E intersection F equals to P of F or P of E into P of E on F or into P of F on E. That's all. Now, let us understand better by following some illustrations. You see here, the illustrations can make you better understand. Let three cards drawn successively without a replacement. You see here? Without replacement. Let three cards drawn successively without replacement. So, pack of cards 52. Three cards are drawn successively. Successively means what? One card first you have taken, afterwards another card, afterwards another card, like that. That is three cards drawn successively without replacement. Again, you don't keep in that pack. Once you have taken, it is out only. So that is called let three cards drawn successively. Successively means one by one. Successively without replacement. Once you have taken the card, it is not mixed in it. Okay? Now, then the probability that the first two cards are kings and the third card an ace. First two card kings and third card an ace. What is the probability of it? Very simply I will tell. First two cards must be kings now. First I have taken one card supposed to be king. How many kings will be there? 4 kings will be there. In the well shuffled pack of 52 pack of cards, 4 kings will be there. So 4C1 by how many cards? 52 cards. 52C1. Next, this is one king card. Supposed to be that the king card I have taken. Again, that this card I have taken, no, king card I have taken, no, I did not again replace. It is out only. Okay. Now, how many cards will be? 51 cards. 51 cards remaining. Out of 51 cards, again, if I get king. So how many kings will be there? 3 kings will be there. Because totally in the pack 4 kings only, no. 1 king I have taken out and 3 kings will be there. So 3C1 by 51C1 into next. What is the third
third one ace. Third card must be an ace. So how many aces are there? 4 aces are there. So 4C1. How many total cards will be there? Because I have taken 2 cards, kings, 2 cards out now. So how many cards will be? 50 cards. 50C1, 50 cards only we have left because out of 52, 2 kings I have taken out. So how many aces? 4 aces. One I have to select because I supposed to be that I have taken the third card I have taken must be an ace. That is why I am writing like this. 4C1 by what is the remaining cards? 2 kings I have taken? No, 2 kings. So 50C1. This is the process of multiplication theory of probability. Very simply you can understand. What you have taken? That out of the pack, 52 pack, you have removed it because you did not replace the card. 51 cards will be left. So how many kings will be left? 3 kings will be left. Like that you write. It is very easy. So for that coding I have given. Coding. P of KKA means king S. First if you take card, king must come out and another card king must come, another third card ace must come. Like that I have written. So now P of K I have written 4C1 by 52C1 and P of K and K means what are the left cards here? 51C1. K and K means 3 kings left now, 3C1, 51C1. Yes, KK means 2 kings now, 52 minus 2. So 50C1 like that I have written. If you remember this one or not, you can, if you understand this, you can tell very easily for competitive exams also. If you understand this, this is very easily we can understand. This is nothing but the process of multiplication theory of probability. Let us see some other questions. Here, you see here, drawing cards one after the other, that is successively. Sometimes one after the other, sometimes successively. They use some terminology that gives us the sense of that we are taking one by one, drawing cards one after the other. The probability of event that a king and a queen, very easy. How many kings are there? 4 kings are there. 4C1 by 52C1. King and queen. How many queens are there? 4 queens are there. 4C1. But here, 1 king I have taken out. I did not replace the card. So how many cards will be left? 51 cards. This you have to remember, that's all. First 52 cards, 1 king 4C1 by 52C1 into 4 queens, 4C1 by, how many cards left here? 1 king I have taken out? No, it is not replaced. So 51C1. Over, this is nothing but 4C1 by 52C1 into 4C1 by 51C1 equals to, if you calculate, you will get the answer. So I have written this also, you know very well. 1 king, queen, first king, next queen should come. So first king I have taken P of K and queen I have taken, but on K. On K means 1 king left, 1 king I have taken over and 51 is left, 51C1, like that we will write this. This is the coding only. Whether you write coding or not, it is not minded. But this is very important. This This series is very important. Only multiplication. This into this into this into this into this into. Before this, you have given 3 terms product. No. Now 2 terms product. That's all. Here, another, I will give you another one. Very easy. Very easy. An urn contains 10 black, 5 white balls. Here, an urn contains 10 black, 5 white balls. Urn means one vessel. In the vessel, 10 black and 5 white balls. 2 balls are drawn from the urn, one after the other, or successively. Same model, without replacement. The probability that both drawn are black. It is very easy. For if both drawn are black. How many black? 10 black. How many white? 5 white. So both drawn are black means 10C1 by 15C1 into 1 black I have taken now. This is black now. Another black. How it comes? 10C1. Original 10 black. So 1 I have taken. I did not replace. So 9 will be left. 9C1. Here 15. Total 15. 10 black and 5 white. Total 15. 15C1 first I have put. And then the next chance, how many balls will be there? Because I did not replace, 14C1 now. Here, 1 black ball I have taken. So, how many black balls will be there? 9 black balls will be there now. So, first we write 10C1 by 15C1 into 9C1 by 14C1. That's all. It's very easy. So you can write like this. Very easy. 10C, this is first black ball, 10C1 by 15C1. I did not replace, that is why 15 will become 14 only in the urn. Okay? Out of 14, how many black balls will be there? Because in the question, they require another black ball. That is why 1 black ball is reduced. Because I have taken it. I have taken out. I did not replace. So 9 will be 9C1 by how many total? 14C1. That's all. This is the multiplication process. Independent events. You see, independent events. What are the independent events? Events are different and they are independent. A die is thrown. If E is the event, the number appearing is a multiple of 3. That is the E, event E. Number appearing is a multiple of 3. And F event be the event, the number appearing even is even. The number appearing is even. So first one is, a die is thrown, E is the even, number appearing is a multiple of 3, and F be the even, the number appearing even, then find whether E and F are independent. It's very easy. So die thrown, no. What is S? 1, 2, 3, 4, 5, 6. What is E? Multiple of 3, 3, 6. What is F? Even numbers 2, 4, 6. How easy it is. What is E intersection F? E intersection F, 6. That you know. Then P of E equals to, how many P of E here? E is 2. S is 6. P of E is 2 by 6, 1 by 3. F 3. So, P of F, how many elements? 3 elements only. P of F, 3 by 6, 1 by 2. And P of E intersection F, how many elements will be there? 1 element. P of E intersection F, 1 by 6. Clearly we can understand P of E intersection F equals to P of E and P of F, because here if you get like the P of E intersection F, what is it? 1 by 6. What is P of E? 1 by 3. What is P of F? 1 by 2. What is P of F? 1 by 2. What is P of F is 1 by 2. P of E is 1 by 3. You give me 1 by 3 and 1 by 2. What do you get? 1 by 6. Have you got 1 by 6? P of E intersection F 1 by 6? Yeah, P of E intersection F 1 by 6. In case P of E intersection F equals to P of E into P of F, then E and F are independent events. That's all. P of E intersection F equals P of E into P of F. If you prove wherever at any time, then they are, those elements or those events are called independent events. You see here, you can understand. I will understand by John Venn diagram. Here in this Venn diagram, this is E, this is F. What is this? E intersection F. What is this? This one. This one. What is this? E intersection F dash. Okay. What is this? E dash intersection F. Sets you learned in 8th, 9th classes. John Venn diagrams explained you in the earlier stage to understand about sets. This is total universal set. This is E. What is E dash? The other portion is E dash. Okay. So, here this is total F. So, in the universal set, this F, if you remind, the other portion is F dash. That F dash and this, that F dash into this E, that F dash and E intersection, this one only, no? F dash, no. F dash means this is F, remaining F dash. So that F dash and E intersection portion. Intersection means common portion. This only, no. This is this only, no. This is intersection F, no. Totally this is E dash intersection F dash, no. Now you see. P of E. What is P of E? Do you know what is P of E? Yeah. P of E means this one. E is this one. E intersection F, this one. E intersection F dash, this one. This one intersection F dash. This one E intersection F. This portion and this portion if you take, what will be? E. I applied all sides, both sides, P, like that. First of all, you have to know the set theory. Afterwards, you can apply P out this side and that side. That is probability. P of E intersection F dash, I have taken this one here, equals to P of E minus P of E intersection F. P of E minus, what is this? According to multiplication. Multiplication you learn, no. P of E intersection F means P of E into P of F. And this is, and P of E, if you take common, 1 minus P of F. 1 minus P of F is, what it is? P of F dash. That you know. So P of E into P of F dash is nothing but P of E intersection F dash. You see how logically it is proved. So it is proved that P of E intersection F dash equals to P of E into P of F dash. P of E into P of F dash. This we obtained. Therefore, E and F dash are independent events. This is the best John Venn's explanation about independent events. Please observe, this rule may be useful for you for the competitive exams. If A and B are two independent events, then the probability of occurrence of at least one of A and B is given by 1 minus P of A dash into P of B dash. That is, P of A and B, another result is 1 minus P of A dash into P of B dash. This is a very good result. This is very good result. P of, here observe, A and B are two independent events. Then the probability of occurrence of at least one of A and B, at least one of A and B, at least one of A and B means, at least one of A and B means A union B. At least one of A and B means A union B equals to 1 minus P A dash P B dash. How to get this result? This result sometimes may be asked in intermediate as a tough question, and competitive exams, 12th class CBSE also they will ask this question, and for 6 marks, 3 marks, 4 marks like that. And for competitive exams, this as a formula basis, one question will be, one description will be given, and then this formula you can use. P of A union B equals to 1 minus P of A dash P of B dash, or P of A dash P of B dash equals to 1 minus P of A union B, like that also. P of at least one of A and B, it is nothing but, I told just now, at least means A union B. You know the addition formula that P of A plus P of B minus P of A intersection B, and P of A plus P of B minus P of A into P of B, because independent events, P of A plus P of B, common 1 minus P of A, and P of A plus P of B, P of A dash, because 1 minus P of A is A dash, 1 minus P of A is P of A dash. So P of A can be written as 1 minus PA dash plus PB PA dash, and now 1 minus PA dash common, 1 minus PA dash common, 1 minus P of B. Okay, now here 1 minus P of A dash. What is 1 minus P of B? P of B dash. So we got P of A union B. P of A union B as P of A union B as 1 minus P A dash into PB dash if A and B two independent events. Thank you.